you want this after? No. Okay, I believe this is the official start. So we are competing with raw materials and recycling, so it's never an easy task to do, but we will do our best. Ladies and gentlemen, hello. For the people who are online, hello, thanks for following us. And we will kick off the session on the Battery Young Research Award right now. When I was asked to moderate the session, I asked myself, okay, how can I explain how talent is important to an industry like Umicore? And I guess this reasoning is valid for other companies in the battery space. And I came to the conclusion that there were, for me, 3 points. Because the business model we use in usually the industry, we need talent. If I take the example of Umicore, we have a closed loop system, so we turn metals into materials thanks to chemistry and material science, and afterwards we are able to convert these materials back into the metals with recycling processes. So we use chemistry, we use metallurgy, we use material science, we use engineering. This requires talent, this requires people who are very well educated, and we need them. Also, the amount of R&D we do for Umicore, we are spending more than 250 million every year globally for R&D activities, which is quite a lot. And we also try to be as diverse as possible. So we have 35 different nationalities in the group that do innovation, because we believe a diverse way of thinking is always better. We have also about 15 global locations where we do R&D. And we are trying to move towards gender balance, which is not always easy. And we are already at 25% of women in the workplace doing R&D activity. So that's the first reason that I found. And then the second reason that I found is the activities that we do require talent. And if you consider battery materials, this is something we've been doing for more than 20 years at Umicore. Basically, we can give 1 battery per smartphone per people on the planet if we would like to. But this requires also a lot of talent in being able to scale up operations. So it's not just product development, but that's also a lot of process engineering, trying to make possible providing a battery not to a happy few, but a battery to most of the people that need it for the different applications. Recycling, this is the same. It's also a very important process, which today is not at a big scale because the market is not yet there, but soon all the scrap and all the end-of-life waste is going to come back, and we will have to be able to treat it in the best way possible, in the most sustainable way possible. So here as well, people with environmental science background, people with ecotoxicity background, a very broad range of people are needed for that. And then I also found the third reason is because of the ambitions that we have, the battery industry. If you look at all the forecasts, they are never right, but they are always very impressive. And so this means that every company is going to be competing for a lot of talent in order to be able to fund, to have people doing the R&D, be it in product innovation or in process innovation. So for me, it's quite logical that we need a lot of talent, and there are a few things that we can do. The first thing is to educate or re-educate, because some people that are educated may want to shift and re-educate themselves. I'm not a material scientist in battery space, for example, but I learned, so it's possible. We also have to make sure that we are able to retain talent in Europe. We are very good at creating PhDs, and sometimes the PhDs leave the continent because they found better ways to work. They have more access to grants. They have a more stable future ahead of them. So we have to be able to keep the talent. And why not also try to attract the talent from outside and to offer them very good positions in Europe where they can bring also an outside view to a problem, which is always very good. So this is something that means that we have to work quite a lot together. It's not just the authorities that we often say you have to do this. It's also the universities, the academic organizations, the industry. The more they will work together, the more it will be actually helpful. Walter and Sylvia, they will be talking about these programs that bring together all the best souls and the best people. And afterwards, with Wei Han Li, we will have an example of a stronger development that won the prize. I would maybe like to finish at simply telling you how at Umicore we try to do humbly our part, because We are not there to solve the problem for everyone, but everyone has to do the best they can. And we try to do three things. We engage with universities, research organizations, also vocational schools actually, because it's not just the most how to say this in English, the people with the highest degrees that need to be active. We need people all along the process, and that includes from the technicians to the postgrad to the postdocs. So we try to really engage with them to tell them these are the needs that we are going to have. They are going to be needed in that time. The time frame is that one. So we really need to ramp up the education capacity. Then we support a few international networks and initiatives like those that you can see on the nice roll-up there. So that's Batteries Europe, Batteries 2030, BEPA, and the IPCAI is also something where we are active because we believe this is a place to be. And then, last but not least, and I think it's actually the most important, we welcome students to carry out R&D activities at Umicore. This is something that we do. That gives them an exposure to what it is to be in the industry. And also for us, it gives us exposure to people that maybe we want to recruit afterwards to have them working with us. So this is really, for me, the way I wanted to shape the problem that we have is actually a big problem. We've been talking about access to raw materials for many years. Maybe access to talent was not given the right amount of attention. Sometimes it's difficult to focus on two things. But talent is very important. So talking about Umicore and finishing with this, of course, if you would like to join us for this adventure, I would invite you to check on our website. It's called careers with an s.umicore.com, and you can see there all the open positions in the battery space, whether it's in battery recycling, whether it's in battery chemistry, or other activities that are connected to that. So now I will move to the next, if it works. Oh, sorry. Yeah, so it's going to be Walter. Walter is a senior consultant at Clarence. He's the executive director for the Battery European Partnership that you may know under the name BEPA. And BEPA is actually the grouping of different players which are dedicated to creating this European battery ecosystem. It's under the form of a partnership, which means that money is provided by the European Commission to work on some topics that are transformed into grants that some of you may be using for your research. And afterwards, this is then transformed into results that go to the industry, ideally. Walter has a background in international relations with 10 years of working experience in the energy sector, and he has been working on energy storage and grid development, so it's quite obvious that he should be talking about the topic right now. And Walter, I will give you the floor. Thank you.
Good afternoon, everybody. Thank you, Fabrice, and thank you, Umicore, for sponsoring this Young Scientist Award. We really appreciate the efforts that you make in all the different associations that were mentioned, and also on a personal level, Fabrice, I want to thank you on all the efforts that you are doing, even to preparing this session on the side of the swimming pool a few weeks ago. So thank you for that. As you can see, I am the executive director of the Battery European Partnership Association, as mentioned by Fabrice. Being executive director is not something that runs in the family. What does run into the family is being a teacher. My father was a teacher, my grandfather was a teacher, my great-grandfather was a teacher, and my great-great-great-great-grandfather, they were all teachers. When my great-great-great-great-grandfather for the first time went to set out and make this little village school, they said, oh, there's this little village which doesn't have a school yet, you need to go there, you need to set it up. So he went to the nearest town by train, and like a rickety train somewhere end of the 1800s. And he went off the biggest city that was close by, had to walk through the streets for half an hour. And then when he was there, he just like looked around, lost, didn't see anything. Then saw a farmer in the field, and he said, sir, can you tell me where the village is? And the farmer said, if you take 2 more steps, you're already out. So it's a very, very small village where he went. And what this has taught me is that there is really a power in education to transform. Because from that little village and through the generations that my great-grandfather until my dad has been able to teach the people from this village, I can see that they are coming back to us and say, oh, I remember your granddad taught me this. Thank you, they say to my dad, for teaching me this and this and this. So it really shows that it really has made me very acutely aware the importance of education and the impact it can have on the society, small, but also big. And that's what we're going to talk about today, because we have big challenges going on in Europe, which is often the switch from, for example, internal combustion engines to battery-driven cars is represented as a technical problem. We need to take the engine out, we need to put a battery in. But it's actually much bigger than that. And if we want to really fulfill the goals of the European Green Deal, then we really have to change society. And this is really not just a technical transformation, it's a societal transformation. And in order to get the people to help with this societal transformation, we need to increase their skills and educate them to do so. So in the previous iteration of Batteries Europe, the task force on education provided a figure which is really enormous. Like, we need 800,000 reskilled workers in the battery sector by 2025, which is an enormous number to be trained. And then if you imagine how far this trend will continue in the future, it will only be more. It won't be 1,600 in 2030. No, it will grow exponentially. So we really need to tackle this question now on how to unlock the different levels of talent and to upskill basically the entire population of this continent. What mentioned by Fabrice as well is that we don't need just education on the academic level. We definitely need new smart PhD to discover the new breakthrough technology that we still don't know yet. But what we also need is the really training on a vocational level. But also we need education closer to home, to the general public, who also need to make fully aware what this societal transformation means for them, and also give them the right information to make the informed decisions. So when they see an article that, okay, a battery needs mined materials, that they can compare it to, okay, but an internal combustion engine has mined oil. And people don't make that connection that you need to mine anyway for your transportation, and just the battery is just a different way where you look for minerals and not for fossil fuels. So when this partnership set out together, so BEPA together with the European Commission under the name of the BAT4EU flagship, we were, I at least was very happy to see that education at least got a line mentioned to it, that we not just should focus on the money and the grants and what are the strategic decisions, but we should contribute with this partnership with all the companies and research centers and the European Commission together to invest in this into education. However, it was just one line, so it was quite difficult to see exactly what we're going to do in the partnership. And that was actually one of the first tasks that I started going with, is to sort of make an inventarization about how actually big the skills gap is and what it's already is being done. So as I said, a lot of work was already done in Batteries Europe to see how many people we need in the future. And actually, the good thing to see is that there's a lot being done. It's always easy to focus on what still needs to be done and what's still not being done, but there is already a lot of efforts on their way. If we look at, for example, the Alistor project, which came out of not even the framework program before Horizon Europe's Horizon 2020, but the one before that, in order to help indeed set up these PhDs in the battery electrochemical sphere. And now also having moved on with the Erasmus Plus mission to train more master students as well. So that's really encouraging to see, and you see more and more people trying to make use of this facility to get educated in the field. Of course, there's the Battery 2030 Plus initiative, which is running for a long time and has a strong education component, which we'll talk about a little bit more in the presentation of Sylvia after, but basically also helping to create curricula for universities so they can provide this to their students. And we don't have to invent everything from scratch, but when there is a curricula ready, then we can share that knowledge around. Same goes for the European Battery Alliance and their EBA Academy project, which we have started last year, which is also focusing on trying to sort of standardize and upscale this education activities in the European battery value chain, so that we really not only getting this tip of the highest done, but also like making sure that we scale this up and really make this as broad as possible. Other projects with educational angles right now are, of course, the Leap Planet project, which was a project under Horizon 2020, has now turned into an association. They focus on really pilot line production, so just before industrial scale, trying to set up these pilot lines to try things out, but also they invite researchers to play a part in this. And then, of course, last but not least, there's this push is not only felt by people working solely on batteries. There's now the Automotive Skills Alliance, which came out of the work done in the LBATS and Drives European projects. And really this is looking at it from the automotive perspective, but really adding this also this angle of vocational training to the mix of things that we already have. So a lot of is going on, and some coordination would be in place. So we were very lucky that after the previous mandate of Batteries Europe ended, this network was founded both by, led by Silvia Bodorado in the name of BID2022, and Dimitri Mileka from InnoEnergy and in the name of Batteries Europe, to really get these actors together. And if it's not only to improve, it's really already just to set up this sort of sharing what we're doing, because that's also quite an important first step to make sure that we cover all bases, to make sure that we're not actually competing with each other for the same kind of talent in our programs, and that we really have this sort of unified education approach in Europe. So the EDU Battery Network got going. You see here the members on the screen. We're very happy also to join as BEPA to make sure that this a link of information between our members and the people in the network. It's a very interesting mix between companies, European projects, bigger initiatives. So we really have this really open exchange to see how we can reinforce each other. So the sort of call that I want to make on people here today in the room and looking online is help us close this skills gap, because there's a lot of things going on, as I just said, but we still need to do a lot more. So if you want to join the Battery EDU network, that's possible. And if you have a education initiatives in the battery sphere or in the automotive sphere or in another related aspect, you can register your initiative and you'll be invited to these meetings to see what other initiatives are doing, trying to see how you can learn from them and maybe what you can bring to the other initiatives. You can either join it directly or through one of the projects, of course. If you want to, if you're joining that, then you can be part of the EDU network. And yeah, it doesn't really matter that much if you're doing it from a private side initiative or something that's publicly funded, or maybe even if you have some in-house trainings but you still want to see what other initiatives are doing, just join us. Also, it doesn't matter necessarily whether you're offering these services, educational courses on a global or European or national or regional level. Actually, we also need all of those levels working together to have this entire transformation. So even if it's just a national project on education that you think can be interesting, where you want to learn from other European projects, or you're thinking, okay, hey, we have this figured out here for us, let's share this with our European partners, you're very welcome to do so within the network. So you can contact us at BEPA as an entry point. Also, we're just trying to sort of come together with a database, so even if you don't want to join the network and have several meetings a year to just discuss where things going, if you also want to register yourself and say, okay, we're here, that's also possible. We are building a sort of database so we can also if we have requests for people like, okay, what's the kind of research and of education initiative that we need to target, then we can provide that information to them. So you can also register all your education initiatives with us. Send an email to the BEPA email box, as you can see, or visit our website and leave a comment there. We are happy to see you join us, because there's a lot of work to be done, but I think together with all these initiatives we can make it work. Thank you so much.
Thank you, Wouter. We'll now give the floor to Sylvia. It's always funny to present Sylvia because I think everyone knows her, but I still have to do it. Sylvia is a professor at Politecnico di Torino, where she's responsible for the task force on batteries, and she leads the electrochemistry group there. She's super active in all European activities that you may have on batteries, be it on the side of the projects, where she's the coordinator of GigaGreen and the Stable EU project, and also some national and regional ones. And she's actually active in Battery 2030 Plus, Batteries Europe, and BEPA in different roles. In Battery 2030 Plus, it's, you may know her from the education working group. Batteries Europe, we've been working together on advanced materials for a couple of years. And she's also the co-leader of the task force on education within BEPA. So I think that that would be the best presentation that we have to hear. Thank you.
Thank you so much, Fabrice, and thank you really all to give me this opportunity to give an idea on what we are going to do in Europe in the field of education. A lot was already told by Wouter, and everyone knows, and we already said many times, that we really need strong education in Europe, as we are going to get so many gigafactories, and we really need the skilled people to go to work there on one side, and also very good young researchers and future scientists that really will continue the activities in research and really feed what will be developed in the future at a research level. And in fact, this was one of the topics in which we are working within the work package 3 on education in Battery 2030, where we are, of course, giving a recommendation for new curricula, as Wouter already told, but also we are considering that we need to get very high-level people, skilled and working, and still continue working together. So together with recommendation, we are organizing, Christina's organizing this talented and excellent scientist webinar, where everyone can really learn from the excellent scientists in Europe something more about their activities. And today I want, today we are speaking about the Battery Young Research Award that will be given in a while to Weyanni. I want to just to focus your attention on what we did within Battery 2030 in order to engage next generation of scientists. What we did is the first, what we call the Young Scientist event, that was held in 4 universities simultaneously in Europe. The 4 universities were Polytechnic of Torino, of course, where I'm working, the university in Brussels, Uppsala University, and Warsaw University. We organized some tables where the young scientists, or next generation of scientists, as we will call them for next edition, are met together physically around this table and were discussing about their thought on the future in the field of batteries. Instead of getting only a battery expert, we try to get as much as possible homogeneous table with completely different expertise, so together with battery experts, so that were the most of participants. We also got engineers, chemists, but also economists, doctor in medicine, someone in the more humanistic studies, psychologists, and so on, so that they could discuss together and also have a different point of view, different than those we are used to get each other and repeating many times together. The final scope was the preparation of this manifesto that was presented yesterday during the General Assembly of Battery 2030, and that will be presented in more widely and better during the Nano Innovation Conference in Rome, so you are invited to join us there, and where we meet physically with those guys and people that did the work. Sorry, I went too fast. I just present you the agenda of the meeting just to let you know how we organized this event. We got a part of the welcome of the European Commission, the presentation of Battery 2030 head by Christina Edstrom. We got some very short speeches, no more than 10 minutes, that were in somehow giving inputs to young researchers for their discussion. So we got these very small and short speeches, and then 50 minutes of discussion around the table, again 10 minutes of inputs, and then discussion. All these speeches were broadcasted simultaneously in the 4th university, so all the scientists discussing were influenced in somehow the same way from the speaker that were, for example, in Torino physically, but then broadcasted in the other university, and the same for other topic. And as you see, most of them were more focused on batteries, so we got the Batteries for Future by Robert Dominco, the one on materials for e-mobility from BASF, the full electrification Volvo, ACC as battery producer. But then we also get 2 speeches on more societal impact, and also from one economist of a very important bank foundation that gave a completely different point of view. And the conclusion were that these people started to discuss together and work together. We got more than 120 participants, so we can say that we got a good representative of the next generation of people in Europe. And the one you can see with the photo on the left-hand side are the table leaders. So each table got one table leader that take the role of take the discussion, make the summary, and discuss. And then they met for the whole month of July, all weeks, at least once a week, for discussing and writing and preparing the manifesto that was shared with all the other participants, and now is ready and will be published in next days on Battery 2030 website. So really, I recommend you to go to check it and to get their point of view. That will be very informative and very useful. This is the manifesto, a perspective from young scientists in Europe, sustainable batteries, full cycle, sorry. And they also prepared a visual abstract with their main specific topics. So please come in Rome when they will present their activity. But I was just to give a very simple highlight on the main topic, the message they wanted to share with us, that are, of course, one of the main topics is sustainability. This is their future, so they want that they will leave them a green world where to live. Creating multidisciplinary teams, this idea to start putting together around the table people with different expertise was very important, and this allowed them also to think that this will be very important. Cooperation between academia, industry, and customer is very important. And then the last message they sent that they want to keep to be engaged in the future. So what we also put in the work of next future Battery 2030 initiative is to organize a community of young scientists that still continue to work together, be engaged and available for discussion with companies on one side and with the European Commission giving their point of view. That's, I think, is very important. So you will see also some picture of these groups. There were very good, beautiful days, so also sun was shining and everything went really very well. So efforts made today will be the breakthrough for the future. And today, I really want to say that I also chaired the session on this battery Young Research Award. Let me say that we got 9 PhD theses to select. They were really very, very high level. It was very difficult to make a good selection. Our selection was done taking into consideration 3 aspects: the quality of the thesis, the impact of the thesis, and finally the video, because they have also to prepare a video in which they show the main topic that were treated. And so I'm very proud that Wei-Han won this prize, and so for sure I will thank you all for the kind attention. Okay, this also.
Thank you. Okay, thank you so much, Silvia. I think that the idea of structuring the voice of a younger generation is something that we need, because every year we are getting older anyway, so we need to start replacing us and also have the view of the young people. So now I'm going to give the floor to Wei-Han Lee. So he's the winner of this year's award, but I also wanted to extend my congratulations to all the other, I would not say competitors, but those who submitted a very high-level thesis as well. Wei-Han is a young research group leader at the Institute for Power Electronics and Electrical Drives in Aachen, which is a very well-known name in the space. His interests are on battery digital twin with physics-based modeling and machine learning, battery analytics and monitoring, aging estimation and lifetime prediction, battery fault detection and safe monitoring. Actually, all keywords if you are considering sustainability, because it's also is there. It's not just in the making, but also in the following of the activity of the device. He's one of the 3 awardees of the German Study Prize in the Natural and Technical Science section, which is one of the highest prizes in the field for the young scientists in Germany. And he's also the winner of this year's Battery Young Research Award. So, Wei-Han, you have the floor.
Yes, thanks for the kind introduction. And the title of my talk today is the same title for my dissertation, The Battery Digital Twin with Physics-Based Modeling, Battery Data, and Machine Learning. So we know that batteries are the fastest growing storage technology in both transport sector and energy sector, and are playing a crucial role in the fight against climate change and the future energy system. Although the batteries are developing into a widely used technology, they still undergo performance degradation with time during usage as well as the storage. As an example here, the data from Nissan Leaf show us that the remaining capacity of the battery packs degrade with different speed, and the variance is increasing with time. The degradation of batteries is directly connected with the key concerns of the consumers, as the degradation reduces the driving range and safety can be accelerated by fast charging and increases the cost of the electric vehicles and reduces the residual value of the vehicle after an extended period of time. Therefore, the degradation is one of the most important limiting factors for a wider acceptance of battery-powered electric cars in the market. In order to satisfy the customer concerns related to battery aging and degradation, I provided a comprehensive solution in my dissertation covering diagnostics, prognostics, and optimization of the degradation, so that we are able to monitor the battery state in real time, predict the battery lifetime accurately, and optimize the battery use to restrain the aging. My talk will include 4 main parts, and I will begin with the introduction of the general idea of my work and give you an overview of the developed battery digital twin for the full life control of batteries. To control the battery behaviors, we know that the battery management systems are a very important component responsible for measuring the current voltage and temperature signals of the batteries, enhance the safety with cell balancing and charging control, and monitor the states of batteries with models and algorithms. However, the state-of-the-art BMS is faced with problems in low computation power and low data storage capability, and therefore logging of the operation data and application of advanced battery analytics algorithms is very challenging. To overcome these obstacles in battery management today, BMS is revolutionized with bidirectional communication capability by Internet of Things and cloud analytics of the battery data with cloud computing in this way. The operation data of the battery systems measured and preprocessed by the BMS can be transmitted to the cloud, where the high computation power can be used and advanced battery diagnostics algorithms can help us to understand the aging and predict the lifetime of the batteries. The states of the batteries are not black box anymore and can be visualized to the users. The cloud-based battery management makes it possible to build up the digital twin of battery systems and bridge the physical and the digital world of the batteries so that we can make control of the entire life cycle of the battery systems. In 2018, we have prototyped this concept and installed this system on a battery systems of our industry partner, so one of the pioneering work in this field, with the developed hardware and software in this work. So the question is still there, how can we use this platform to visualize the battery use and develop advanced algorithms and models in the cloud to help us to revolutionize the battery use? To this end, the strengths of physics-based modeling in the extrapolation and the strengths of machine learning in interpolation and prediction are combined to extend the battery lifetime based on the data collected from both lab test and the field. Within this platform, 12 models, algorithms, and frameworks are developed, covering 7 key functionalities in full life cycle control of lithium-ion batteries from electrode level to system level. We are now able to monitor the electrode level states of the battery in real time, such as the side reaction over potential, which are crucial for the battery degradation in fast charging and low temperature. The parameters of electrochemical models can be identified with the design data-driven framework using artificial intelligence to reduce the time cost from several months to several days while increasing the model performance. With machine learning, the battery health indicators such as the remaining capacity and the internal resistance can be estimated with a small part of the charging data, even under operation or even under some sensor noise, with incomplete input on the vehicle. With the estimated age indicators as input, the developed deep learning model is able to predict not only the end-of-life point, but also the whole degradation trajectory together with the knee point in one shot for both capacity fade and power fade. The developed multi-task learning model further increases the prediction accuracy and reduces the computation burden. Last but not least, we are now also able to optimize the use of battery by predicting the maximum available charging and discharging power based on the internal safety constraints and design the operation strategy, which is adaptable over time to reduce the degradation speed and extend the battery lifetime. Now I will move on to one representing functionality, the degradation diagnostics, and give you a deeper introduction of the methodology and the results. Lithium-ion batteries consist of 5 main components, as we know: the cathode, anode, electrolyte, separator, and current collectors. The lithium ions move from the anode through the electrolyte to the cathode during discharge and back when charging. The degradation in lithium-ion batteries is caused by a large number of physical and chemical, even mechanical mechanisms, such as the solid electrolyte interface, SEI growth, loss of active material, and lithium plating, which affect different components of the cell. As a result, the cell's ability to store and deliver the energy and power degrade until the cells reach the end of life. As a metric for the aging status of the lithium-ion batteries, the state of health is commonly defined using one of the 2 indicators here, so which are the remaining capacity and the internal resistance. An accurate SOH estimation is essential for operation, maintenance, and optimization of the cell, but monitoring the SOH is a challenging task due to the complex and nonlinear underlying mechanisms that contribute to the aging of the cell. As shown on the right-hand side, the cells manufactured under equivalent conditions can also have different degradation passes under the same testing scenarios, where the 48 cells show large variations in the degradation trajectory in the late life phase, resulting in large variance in end-of-life cycles. There are several approaches to investigate this aging phenomena of the battery. In laboratory, we can conduct the post-motive analysis by opening the cells and analyze the material changes. These invasive methods are apparently not able to be used for working cells which are still in operation. The most widely used online SOH estimation approach in industry is the parameterization of battery models. The main limitation here is that their accuracy depends highly on the choice of underlying battery model and the identification of the parameters of the model to capture all the degradation mechanisms is a challenging and computationally expensive task. A controlled experimental approach is also widely being investigated. For example, the so-called incremental capacity analysis uses the charge voltage curves typically obtained by passing a very low current through the cell to simulate the equilibrium operation of the battery. However, such data is hard to be gathered in real operation scenarios. To avoid such limitations, there is a need for methods that can work with sensor data available from our standard BMS, usually from a working cell. Here I developed a new online aging estimation framework with the charging data in operation using neural networks. So the voltage and time samples from the raw partial charging curves of the constant current charging operation of the cell are used as inputs to the model here. So this sensor data is relatively easy to obtain from the vehicle during charging, and the charging is typically a uniform process over a cell's lifetime, since it usually happens over similar periods of time at a charging station. As we can see, the shape of the charging curves is changing during aging. Here, from the charging data of a new cell in dark blue to the data of the aged cell in light blue, this feature is correlated to the battery aging and can be used as input to the neural networks to estimate the battery aging status. The choice of the input data window must be balanced between the availability of the data and the information contained in the input. Commonly, the charging of the vehicle may begin from any value of SOC of the battery, but typically will go to 100% before being discontinued. Therefore, it is clear that the upper part of the CC phase of the charging curve will be reliably available over the cell's lifetime, and therefore is the choice of the input for our machine learning model here. So what is a neural network? Maybe for most of you it's familiar, but I will give a very short introduction. So neural networks are a type of supervised machine learning method, so which has gained a lot of success in different application fields. The neural networks consist of several layers of neurons, and each layer has a set of neurons to learn the feature of the input provided. There's also a weight associated with the neurons which tells it when to activate, and these weights get optimized as the neural network learns through the training process. Regression methods, for example, the linear models, need feature extraction from the raw data, which requires a lot of domain-specific experiences. But the deep neural networks, the deep learning, consist of several layers and have the ability to do efficient feature extraction from the raw data directly. This is achieved by optimizing the weights of the neurons based on the prediction error in each training epoch. So in this work, we used long short-term memory, LSTM networks, which is the type of recurrent neural network capable of learning order dependence in sequence prediction problems. This is the behavior required in complex problem domains like machine translation and speech recognition. For our case, the size of the input matrix or the number of time voltage samples is also changing during aging, which requires a processing step for regression methods. But the LSTMs can work with inputs with varying sizes and is ideal for the estimation of the SOH of the cell using this charging data. As shown on the right-hand side, the best performing network after training was found to be a bidirectional LSTM network with 1 zero masking layer, 4 LSTM layers, and 2 dense layers. So the final framework of this online capacity estimation can be split into 2 major parts, namely the initial training of the model and the development or the deployment of the trained model to vehicles in operation. The experiments to gather such aging data are the first step, after which the obtained dataset is processed and stored in the cloud to be used for model training. The main task of the cloud server is to train the model with the data provided and serve the best performing model to the devices connected to it. The local devices can also forward their gathered output data, the new input samples, and other metrics to the server, which can be used for the future improvements of the models. This cloud connectivity feature is also the key factor here that enables a continuously updatable deep learning model for any functionalities in our BMS. And the local inferences can then be computed on relatively cheap embedded devices within the BMS of electric vehicles, since the deep learning models are very computationally cheap to evaluate. In order to verify the model performance and demonstrate the computing capability of using such models in future BMS, I have carried out a comprehensive validation with 3 scenarios reflecting the real operation scenarios of BMS. As introduced before, this model is meant to be useful in small deep learning capable embedded devices which could serve as the processor for the data fed from the sensors attached to the BMS in operation. This will explore the possibility of using such GPU of the modern electric vehicles to support a better battery diagnostics. For example, the powerful vehicle computer of Tesla shown on the left-hand side. To validate the on-edge performance of the model in local devices, a small onboard computer specially designed for neural networks, the Jetson Nano, is used in this work. The so-called processor-in-the-loop validation was done by feeding the raw charging data arrays to the Nano, from which the capacity estimation model takes the input point by point as it would do in the traditional BMS. There are 3 validation scenarios here. So in the first scenario, the normal data collected from the test is used as input. The first feature shows us that the mean absolute percentage error, MAPE, of each cell in capacity estimation over the entire life are within acceptable tolerances. And the other 2 figures show the comparison plots of estimation against actual capacity in the best and the worst cases. It needs to be mentioned here that the capacity estimates have regular capacity recovery due to the storage between each 2 circling rounds. Although the black curve is the actual capacity, it was plotted based on the discrete checkup points and therefore cannot represent these recovery effects. As a result, the real estimation errors are even smaller than the values provided here. The second scenario highlights the robustness of the model while dealing with noisy sensor data. The data generation method is like the first scenario with the addition of zero mean additive white Gaussian noise, which is higher than most industry acceptable sensor tolerances. The MAPE distribution, the best case performance and worst case performance are very similar to the estimation from the ideal inputs, which proves that the model is extremely robust when predicting the noisy inputs. The mean MAPE for the entire validation dataset is still within 3%. Finally, the last evaluation scenario is used to highlight the predictive ability of the model when some part of the data is even missing due to the sensor error. The model was validated with 15% of the input data randomly dropped before being forwarded to the estimation network. As a key feature of the LSTM networks is that they can work with flexible input sizes. The input window shrinking or extending does not hinder the model operation. The results demonstrate that the model accuracy suffers from the missed data more than the noisy data, which is expected since this is a data-based method. However, even with this handicap, the model performs quite well. So from the validation results, we can summarize that high accuracy of the model together with the fast computation times demonstrates its high potential in future industry application. With this battery diagnosis method, the battery health indicator at each time step can be determined and logged within the digital twin for the battery system in the cloud. So after the deep dive into one of the 12 representing models we have developed within the battery digital twin, I would like to summarize the main contributions of my dissertation. So the main contribution of my dissertation is the delivery of solution to monitor, predict, and control the battery dynamics in both mobility and energy sectors with the battery digital twin. By integrating the information in data collected from both lab and operation field with the physics-based models and machine learning, the 12 models, algorithms, and frameworks are developed covering 7 key functionalities in full life control of lithium-ion batteries from electro level to the system level. This solution satisfies the customer's key concerns in batteries and contributes to the acceleration of the transport, electrification, and energy transition. It not only contributes in the viewpoint from research, but also attracts a lot of attention from our industry partners and generated new commercial opportunities, such as the digital certificates for batteries, the battery warranties, and insurance and predictive maintenance. Thank you for listening, and I would like to looking forward to your questions and discussions. Thank you.
Thank you, Wei-Han. Thank you so much. I would propose the other speakers come to the stage, and we'll start the Q&A panel. I think we have more than enough time, actually, so I hope you have many questions lined up. Yeah, go ahead. Before looking at the screen, maybe I have one general question on which I would like to have your opinion, all of you. Could you share one example of thing that you believe should be tackled right away to close the talent gap? So something that if you had a magic wand, you would do. I mean, Christmas is not too far away. And next to that, is there like a best practice, an example that you have seen somewhere in a country? It can be outside of Europe, something that you said, wow, we should be doing something like that in my country, in my city, in my university. Some best practice that you have on your mind. And I will give the floor to Sylvia, maybe to start. You have a mic, yes?
Yes, it works. It's really a hard question. I have no magic wand, so it's very difficult. But I really believe that even the to talk and to tell and what is happening in Europe and giving much more flawless possible to knowledge and also to tell stories related to success in this field, and can also be for sure important. And I think that we started this year with this new idea, as I showed you before, of putting together new scientists, next generation of scientists, so people that will really take our role in next future for sure, because as we were saying, are becoming whiter and whiter, and not only that. And so for sure that will substitute us. This will be very important, because they really need to be main actors and really the protagonists of the future in this field. So we really need to get their opinion, their ideas, and start working together then so that they will do the work and start working together with their next generation. So to get a sort of, let me say, network or group of people that still continue working together and will be enlarged time by time, I'm really very sure that this will be a good way to get people engaged and really in love with this field. So as Christina told at the first beginning, this has to become a sexy topic, because we really need the people. I was discussing also just before outside with some company. People said, you have to help us to find new people that come to work with us. This is very, very difficult, even for talented people that want to remain within the university framework and work there, get their PhD. A good way is really to get a sort of PhD together with sponsored partially by companies, so that they are ready and to work directly in the companies. These are very good, let me say, ideas and work to be done. For sure, let's see what future will bring.
Yeah, and for my side, what I think is really important is also putting the money where your mouth is. If we look at the 9 people who were applying for the thesis, I think also some got a scholarship abroad, and it reflects to your point here. So if we want to attract the talent that we need in Europe, we also need to be willing to invest in them and give them the financial means to do so. So that's something that I think is very important in that respect.
Thank you.
So maybe I can just talk something from my own experience. So I'm from a group which we have a lot of freedom for us as the research associate to do research ourselves. And we are also able to manage different projects ourselves. So this kind of freedom in research, I think, is the source for us to develop new models, new functionalities. That is also for the industry important and also amazing. And this also makes us possible to look into the industry, what is really the need from the industry partners, and also develop our solutions for them. So this whole loop of collaboration and combined with the freedom, I think this is really important for the younger researchers in Europe.
Thank you. Maybe staying with you, Wei-Han, it was a very good example, the thesis, to show how multidisciplinary the battery space was. For everyone that would doubt that it's super broad, I think now the proof is there. It's not just materials or processes, it's also all the IT, digitalization, machine learning. Machine learning, I would believe that we are just seeing the first things that we can get from machine learning. So if you extrapolate in 5 years, if you come in 5 years to talk to us again, what will you present us?
So I personally also didn't imagine or know from 5 years ago when I start my dissertation. I also didn't know the machine learning and battery will be so close right now. And there are so many different applications, not only in engineering where I'm from, but also in material science and other in recycling and so on. So I really think that so it's just a tool, I must say. It's not something that it can do anything. No, it's not like that. So it's just a mathematic tool that we can use together with our physics understanding so that we can optimize the way we do in research and in industry applications. So in my group, what we are doing is, because we are working very closely with our industry partners, with the automotive partners and also stationary battery system partners. So we would like to hear their questions or their really need and try to use such tools to solve such problems. I see for the next 5 years, there will be an increasing need for us to combine physics and machine learning. I really think that that is the future, because with pure data-driven models, so sometimes it will fail. when you do not understand the physics, but some standard physics-based models or physics-based methods. So when we have a lot of data from the field, right? So we have the IoT, we have the 5G technology. We are gathering so much data from different vehicles, stationary battery systems. How to use it? If we only use the standard models, is not possible. I think we should find some point so that can enable such applications. I think that will be the future.
Thank you. For me, what is also unclear as a project in the future is how will machine learning help us to be even more sustainable? Because I think that is a fantastic help. I mean, you have shown that actually it's helping us to be more sustainable, but it's actually going to be all across the battery space, machine learning. How can it help us to be more sustainable?
So on one side, I think machine learning, as I said, can be used as a tool to further develop the battery technology. So battery itself is the sustainability.
Yes.
So for our energy sector. And the other side, we need to use machine learning for this topic. So for example, so some tasks, we can do it with some simple models. We do not need to train it in the cloud using a lot of electric powers, right? So if we do that, it's a waste of energy. So that is not sustainable. So how to use machine learning and data set in a way so that we can do everything sustainability, that will be another important topic.
And on sustainability, maybe it's more for the other colleagues, is if you look at the battery space, there are many disciplines within that space, and everyone is working, of course, on their little corner because they have the materials people, you have the recycling people. For me, the common thread is sustainability. How can we use sustainability in a way to get people to talk more together, to talk the same language a little bit? How can we structure this maybe better in Europe?
Yeah, I think you're absolutely right. This is one of the threads, and this is one of the areas where Europe can distinguish itself as well in terms of competitiveness to have the sustainable thread. And we are trying to set up sort of transversal task forces within the new batteries Europe BEPA configuration to really help this discussion get going, not only on sustainability, also on digitalization. Just basically to make sure that all those efforts in the different fields on digitalization get together and talk about it. We're going to have a call, for example, on advanced digital twins for manufacturing, something that we will talk about tomorrow as well. So if you're interested in the session, tune in tomorrow. And what's also very important in that sense is working together with the people who are focusing on the robotics and AI side themselves, without necessarily looking at batteries, because they are doing some very interesting stuff that we can learn from again as well. And they had actually their conference before the summer, and they had a session is can a robot win the Nobel Prize? And they invited some of our scientists from the Battery Partnership as well, because they are working, especially in the Big Map project under the Battery 2030 Plus guidance, to work on this, to close the loop and have closed the loop research 24/7. And discoveries that come out of that, who owns them. Yep. So there's a lot of new things going on, and I think that we should work together, especially here in Europe, to create those platforms that we can together on digitalization, on sustainability, to sort of tie those loose ends in the different sectors.
If I may add, also this kind of activities in digitalization and the use of robotics, the use of digital twins, it's sustainable itself, because we can do also less practical experiments, try and error, so we will focus more on our research, going to adjust, let me say, parameters in order to be ready for production. For example, if you have the digital twin of the production line, and somehow you can, instead of trying to get the best calendaring parameters, the best porosity of your electrodes, changing the composition of the slurries and so on, you can do that with your digital twin and then try for once, instead of making a lot of trial with using energy and materials, of course. And this is itself a good way to be sustainable. And as we try to demonstrate also with this event I presented today, it's really dramatically important to make people with different expertise to discuss together. For example, during one of the speeches that was better welcome was the one of the economist. She was telling us how all the activities in research and the development are really strongly guided by economic affairs in somehow. If the banks, if the foundation put money in one specific resource and not in the other one, the game is done. I don't know. We cannot choose anymore. So, and for sure, again, what Wouter was saying about the possibility to get money, to push the development and to transfer the excellence we have in research available in the world within the new curriculum to be always updated day by day, this will be dramatically important. It's one of the topics of BATE 2030.
And I was also thinking about your presentation. It gave me the impression that until now we were talking a lot to the younger people, but talking to them, and now we need actually to listen to them.
Exactly.
And
Yes.
and not just to the guys who are in the battery space, but the economists, the social science, maybe psychological people, I don't know, because it's a very broad problem. And if you look at the way people oppose batteries in the civil society or in the information in the media, there are a lot of information that we need to control, correct, and educate people much more. And based on that, I was wondering how we could better talk to the people about batteries. Because if you open your newspaper or if you go online, you will see a lot of very stupid things about batteries, but they are there. And people have a tendency to sometimes read the stupid things more than the other things. So how do we use these students to actually make sure we control all the disinformation that is out there?
So I don't know if we have to use those students, or in any case, what was really very important is that we have to educate and train the trainers on one hand, because really we need to start from, let me say, very young students, not only at the university side. So no one arrives in Italy, at least I'm sure, at the university knowing what is a battery. So they know that's that device that you put somewhere, or maybe there's a lead-acid battery in the car, but that's no more. But they do not know how they work. They said, okay, they are full of toxic things and so on because of the info. So we really needed to train the trainers, and this is one very important topic that we have to tackle in next months for sure, so that they are also ready to start to transfer information to younger guys that will bring them at home and so on. And for sure, we have to be very available for journalists and so on to give interviews and trying to say the right things in the right places so that everyone can be reachable. We have a really very terrible period in which we have so many trouble and energetic issues and crises today. I always see people that say, okay, what we cannot go toward getting batteries and so on. We have to regasify gas, methane and so on. But really we need to look at long future and think that we have really to not, okay, we have to solve the issue today, but for sure to think very long, and in order to get sustainable, renewable energies, batteries are the solution. I think the future will be a sum of different possibilities that will be combined together. No one is to be is the demon, and the other one will be the one winner, but for sure we need to give the right information so that people can choose. Nevertheless, they have no choice. We have no choice.
Yeah, I totally agree. I think, especially for the young researchers, the young scientists, it's very important to speak loudly what you are doing. Especially, for example, if you are doing some fantastic research, spit it out, and also talk such fantastic research in social media. I think this not only benefits yourself as a young scientist, but also will attract more and more people getting more and more interested on batteries. I think that is also important for not only for the Europe but also for the whole world in research and also for in the industry. And I also think as the research institutes or the companies, we are responsible for organizing some open access events, right? So that all the people, no matter how they are which education background they have, they should have this access to such research topics, because this kind of events may give them some idea to go into battery industries someday after they grow up, or they may transfer to this. This will be also very helpful for the whole society.
And this is where I actually see the role of the young generation. I mean, the young, not too young, but like doing the master or doing the PhD, is that young people are going to listen more to them than they will listen to us, because they relate, they feel closer. And if we would have a way to, I don't know, explain better what we do, like you have done it in a simpler way for those who are not in the field, I think it helps. But what we also see today is a little bit the result of a lack of investments of many governments into science education and technology education at school. And this is going to take a lot of time to fix. But that's a little bit the issue that I see. And I see that finally we have a question from the audience. And I will address it to, I guess, mostly you, but also to the others. How do you see the transfer of these twins to the second life industry? Different EVs and chemistry, not availability of electrical or aging models of the specific cell type, greater inhomogeneity in aging. I guess this is the best question for you.
Yes, thanks for the question. So we are also working on second life applications. It's a very important topic, especially for battery digital twin, because we know that the possibility that aging-related problems or safety-related problems happen in second life is much higher than the first life, because the battery are already under 80% of state of health, and there will be some sudden errors or faults happening. So the solutions for this will be, first, we will be able to use battery digital twin to log the battery operation data from the beginning time of the application and until the end of life, so that we can have enough information for the second life applications, so that we can evaluate the battery with the battery passport directly in the cloud. But there's another topic discussing, okay, what is battery passport, which kind of information should be involved in the battery passport, and how to estimate or have these values in the battery passport. And the other thing is, so for a safe and reliable battery application in second life, how can we very fast evaluate the batteries with some specific test? So we have the battery from the first life. We need to develop some methods that we can quickly, for example, test the battery in 30 minutes, so which can give us enough information to evaluate the aging, the safety, and so on. So we are working on it, and this really relies on different standard diagnostics methods, and also the standard testing method, and also new sensors. So there are enough research happening, but this will give us a lot of opportunities to develop new solutions, especially for the safe second life. Regarding the multi-chemistry stuff, so I think it's always a very hot topic. Whether it is able to develop some model that is able to be used for all the chemistries. Until now, I will say no, it's not possible. I do not see any model that is able to be used without any transferring directly to different chemistries, because battery is so complex. But what we are doing is to try to accelerate this transferring process. We are trying to develop some methods based on integrating physics and machine learning to increase this generalization ability. So generalization ability is the key word here. So how to do that? We would like to have a lot of data in training, so to include at least the batteries, different battery types in the similar chemistry, and try to learn the physics and have very strong physical constraints, for example, in lifetime prediction, so that we can have some model that can be fine-tuning, right? So with some a small part of the operation data directly for a new battery type, for example, from the same company, although they have changed something, right? So in the material or in the production. So that is the goal for the next 5 years.
So reducing the adaptation barrier.
Yes, or even make it possible.
Okay. I see that people may have questions in the audience. Please raise your hand and the microphone will come to you. I will ask you to make your question short and maybe say from where you are.
Hi, Steve Ellis from Dassault System. We've talked a lot about research and innovation. What about then in production? What role does, or what responsibility does academia have to skill the potential 500,000 EU workers who are going to lose their jobs in ICE as battery moves on?
Very hard question. Responsibility of academia. I think that we really have to somehow transfer what we know and work with companies in order to learn more, because I always say that in all the projects we are going to do, all the contracts and activities with company, we are learning much more than what we give. Sometimes I can be almost sure that is possible. So we have responsibilities. We really have to train both people that will be available for future in the field of battery, make the field sexy, as was already said before, so that even students want to start working in this field and do not feel the attraction more for other fields, like, let me say, all the informatic fields, digitalization. This is very well attractive, that's good, but just say that that word can be absolutely in somehow very close to the one also of battery. The trainers, as I already said. So we make some additional examples. So for example, we did a webinar in which, during the pandemic period, in which the production of cells was showed directly in front of a pilot line. This was a live seminar so that people could ask questions, and then the operator went again on the pilot line and showed what and answer to questions. This is available on Battery 2030 website. It's really very well seen. A lot of people go to check it and learn more. So giving somehow to do some activities to transfer and let knowing to common people, and for sure to who wants to approach to this field, what is already existing in the academia is very important. We have not to keep what we are doing in a closed club, only for, let me say, scientific publication for our career, but really to transfer the knowledge and what we are doing together to all people, to common people in general, and for sure in order to push companies, I think.
Yeah, and to add to that, the automotive industry is not blind either for this challenge. So that's why you have the Automotive Skills Alliance. People coming together in the automotive space saying, okay, we are going to bear the brunt of this societal transformation, and we need to upskill or reskill most of our workers. And they invite academia into their alliance. So it's also, there is the question coming from the automotive industry, so it's not only talking about responsibility, but it's also just a question coming from industry, invite academia and see how they can help each other to manage this transformation. On the other hand, for example, also organizations like the car manufacturers supplier who are here in Brussels as well, lobbying to make this transition smooth, because it's not only the car manufacturers, it's like every step of the supply chain towards that. They are very interested in what we are doing in the partnership, so next month I will have a presentation for them saying, okay, this is on the agenda in terms of research and R&I next, and then they can also look at it, okay, what kind of implication has this for our companies, both in terms of where we need to do our R&I and what are the impacts for our workforce. So it's very much a two-way street. It's not just academia having to tell them what they do, but also just car companies seeing this very accurately, very acutely, and taking actions on it.
Maybe I can give a comment from the industry, because I think this is really a transformation of the mobility that we have in front of us. So we should also, in the industry, maybe open up sometimes a little bit more to really say to the academic what are the real needs, clearly, not vaguely, because it's a pre-competitive field. So keeping all the information, hoping that by a miracle, the academics will educate the right people with the right skills. If we didn't really tell them what we really wanted, we have to meet in the middle. And opening up, I think, is the best way to do. Of course, we have elements of confidentiality. But at Umicore, we often host PhDs, for example, at the labs. We try to provide feedback to the educational programs of universities in Belgium as to what we would like to see more or less. They have to take also other opinion into account, but we believe that this interaction is really working well. Is it going to work fast enough? That's the big question, of course. It's going to be a challenge to transform the sector. I saw there was a question from a gentleman there.
Hello, thanks, Wei-Han, for the talk. Especially, just wanted to ask, what do you think is the future of cloud-based management, sort of given the possibility of sort of onboard diagnostics with like leaner and faster machine learning models, and sort of the increasing need if we were to use cloud-based diagnostics of Internet of Things everywhere and like constant data uploading and so on.
Yes, thanks for the question. So I think that so in the future there will be always some cloud platform for every different car manufacturers their own, because as far as I know, almost all of them are developing some own platforms. But that will not be the only one for battery management. So because I think we need to efficiently, as we said, we do not need to have a very complex model in the cloud only to estimate the SOC, for example. There are already some very good models or algorithms we can use in the embedded BMS. So in the future, there will be some combination of the functionalities local and the functionalities in the cloud. For the functionalities which requires a lot of operation data, like the aging prediction, so for such case, I do think that machine learning, physics-based modeling will play a very important role there in the cloud. But there will be some new topics coming out. For example, how can we do the pre-processing in the local BMS for the cloud, so that we do not need to transfer every second data for every cell into the cloud, because there will be a lot of cost in data storage. Yes. Right? So there's a lot of new areas that need to be further investigated. And there are also some new thinkings coming out, how to distribute these different functionalities, and how can we do new stuff in the cloud.
Thank you. I think there's another question from another gentleman there. Yeah.
Thanks for the nice presentation. I'm Chun Yang from DTU. I have a question regarding a very fundamental feature of the battery, because when we are using battery in the power system, we are very interested about how much energy are there, but actually regarding the battery research, such as degradation, it's more about how much capacity, which is ampere hour are there. And it's also for example, when you drive your car, if you have an electric vehicle, then it's pretty hard to estimate how far the car can drive, even nowadays. And I'm just surprised, like, okay, I'm going to drive 110 kilometers per hour, but this machine cannot tell me how far I can drive, or like it's normally with a like huge uncertainty. I just don't understand why these. With all the good technology happening around, but still these estimations are so inaccurate. And the second one is if you have any suggestions for the new generation PhD students, how can we be a little bit more successful in the future, and what should we do now?
Yeah, it's very, very difficult question. So the first point, state of energy, it is a really very important topic, and I have some colleagues at our university working on this topic, and I am collaborating with her these days to write a perspective paper, and by collecting all the information from the literature, you will know that so only the definition of SOE, state of energy, you can find different ways. Right, so this is really an area that needs further investigation, and it is also much more challenging than the estimation of, for example, capacity, because then we need to also consider the change of voltage, and not only the capacity, but also the voltage. But I do think that is a very important area, and we do need to further work on this topic. And the second question, so I was also a PhD student. I also asked myself at the beginning how to be a good PhD student. I think it really depends on what is your goal after your PhD phase, right? Do you have a goal to go to industry and contribute yourself for engineering, or do you want to do academics, right, and to do research? So this should be probably asked by yourself at the beginning, because this is different, because industry needs some experience, for example, project management and also industry-related investigations, but for research in the academia, maybe there's another way. So I think probably we need to think about it a little bit earlier, and then have a clear goal, right? So, because if you would like to stay in the university, you need to have enough publications. This is very clear. There's no other way. So we need to publish, we need to do research, and that's a very important indicator for all the researchers.
Thank you, Wei-Han. I think we're going to close it here. So now it's the moment where we have to give you your beautiful award. And congratulations. We go there? Yeah. Afterwards, we do a group picture.
Yes, that'll be good. Thank you. Okay,
All of us? I will go on the left. Congratulations. Oh.
Thank you. Thank you. Thank you. Thank you.
I think I'm beginning to see